A box is sliding across the floor from your left to your right. The box is slowing down as it moves. Draw a free body diagram of the forces acting on the box. Okay, let's look at what forces we're going to examine. We're going to look at the weight acting on the box. We're going to look at friction acting on the box. We're going to look at tension acting on the box. We're going to look at the normal force acting on the box. And we're also going to look at the net force. So notice the symbols I'm using: lowercase w, cursive F, capital T for tension. This looking thing, which is actually the Greek letter eta. It's like a lowercase n with a tail on it, and F net for the normal force. All right, so let's look at each one. Let's see, it's a free body diagram, so I'm going to start with a dot. It's called a free body because I don't need all the complications of the body. I don't need to draw a box, just the dot. And as a reference, I'm going to go ahead and just draw a dotted line here just so I can see that's what the surface is. That's kind of my reference there. All right, weight. Well, it's on the Earth, so unless it says otherwise, we're always going to go with that. Notice my vector starts, it touches the dot and goes down because that's the direction the weight goes. And so the weight has been addressed. Friction. Let's see, a box is sliding across the floor from left to your right. The box is slowing down as it moves. Okay, there's nothing else shown on here, so it must be friction that slows it down. So it's going from left to right. Friction opposes motion and it's parallel to the surface. So if it's going left to right, friction goes right to left. So again, my vector will touch the dot and go to the left. And I'll show that with a cursive F for friction. So that's been addressed. Tension. Well, there's no rope or anything pulling the box around, so I don't need to worry about that force. Normal force. Normal means 90 degrees or perpendicular to. So this is the force that's perpendicular to the surface. And the normal force is the reaction force. It keeps the box from sinking down on the surface. So it's going to be pointing up. So here's my normal force pointing up. And I'd like for my length, my normal force, and the weight to be the same, but we'll just kind of go with it for this. So we can adjust that. 2, 3, about the same. There we go. And there's the normal force. The net force. Well, you can see that my arrows don't seem to balance. Up and down seems to balance, but left and right doesn't. And that kind of illustrates what's being told or said in the problem. It says it's slowing down as it moves from left to right. So as it moves from left to right, kind of in that direction, it's slowing down. So that means that there's a net force going in this direction. And the net force is the only vector that we draw that doesn't touch the dot. All the others should always touch the dot. Just so there's no confusion, this isn't a force. I'm just going to get rid of that. So there's my free body diagram.